Hello, everyone. My name is Cynthia Wins, and I am your host for this episode of SLB New Energy Conversations. In today's episode, we will talk about carbon capture and storage, or CCS, a crucial pathway in the decarbonization of hard-to-abate industries. From capturing CO2 emissions from industrial processes to transporting and safely storing CO2 in the subsurface, technology expertise and experience can provide the confidence needed for the CCS market to thrive. Measurement, monitoring, and verification, or MMV, for carbon storage is fundamental to not only ensure regulatory compliance, but also minimize environmental risks. A comprehensive MMV plan helps reduce uncertainty and risk related to CO2 storage. Today, we will learn more about MMV in a conversation with Amir Hermes, Carbon Solutions Business Development Manager, SLB New Energy. Amir, thank you so much for joining us today.
Thank you for having me, Cynthia. Thank you.
So let's just start with the importance of MMV, measurement, monitoring, verification. So what is it? Why is it so important for the success of a CCS project?
Yes, MMV, or Monitoring, Measurement and Verification, is first and foremost a risk management plan, and in many countries as well, it's a regulatory requirement. This is a very important plan to ensure the safety, the integrity, and also the economical viability of CO2 storage project, or basically the S part of CCS, so the storage of CO2. In many countries, this regulatory requirement is a condition to obtaining a permit and a license to store CO2 underground. It is as well a way for project developers and storage operators to ensure that the projects are done economically and that there is an optimization basically of the cost of building and operating these sites versus the residual risk that exists inherently with these operations.
So you're mentioning costs. So when you do an investment in an MMV plan, and this is what you bring to your client base, I'm sure the profitability of the project is as important. Mm-hmm. So how do you go about ensuring that an MMV plan is as effective as possible so that the project can be, I guess, justifiably developed? Is that a good way to ask that question?
No, absolutely. You're right. Mm-hmm. I think CCS is a business after all, and it has to make sense and it has to be economically viable for the investors and for the owners and the shareholders. The cost has to be optimized, and MMV is an important tool of optimization of that cost. So first of all, we look at the value of measurements. What are the measurements that are required and how they are going to impact decision-making and insights and risk management on the project. We optimize those measurements, and so therefore there is an optimization of CapEx, and then we also optimize the frequency of collecting those measurements, which also has an impact on the operating expenditure, or OPEX, of the project. All of that goes, into a program, an integrated program that starts with a model, and it's site-specific, so it differs from one site to the other, and the optimization opportunities are also different from one site to the other. So in brief, it's really a comprehensive program that allows, besides ensuring the safety and the integrity of the operation, to optimize the capital expenditure and the operating expenditure of these projects.
Okay, so technology, obviously, a key element. When you have these technologies, talk to me about the role so that we can understand, like, there's got to be risks. Mm-hmm. So when you implement the technologies, how are the risks and how are those changing?
Yeah, no, absolutely. The technology selection is critical, I think, to manage that risk and ensure that we de-risk the project and we don't add necessarily risk or burden the project with additional costs. So it starts with modeling, which use digital technologies. So digital technologies that we have developed to ensure that we understand and we predict and we simulate the performance of the subsurface. That is a starting point, and then from there we simulate the measurements and how those different measurements will behave over time, over the life of the project. So then we select the right measurements and the right frequency of interrogation of those measurements. When do we need a data point,
Sure.
and what that data point will drive in terms of insights and action for the project. Then how we are going to collect those data points dictate as well the hardware. So the technologies, the sensors, the hardware that will go on the surface and shallow depth, that will go in the well itself, on the wellhead, and that will collect basically those measurements either on a permanent basis or on regular intervals as set, or with a frequency that is defined by the model.
So that sounds like that sounds more like a physical technology.
Yes.
And that, I guess that measures any changes when you implement the plan. So
Yes.
Can you explain more about this? I guess explain more about the physical technologies.
Yeah, no, absolutely. So there are multiple, I would say, families of technologies or categories of technologies. So there are the sensors that will go on the surface or shallow depth to take data points on presence or not of CO2. So from the soil, from the shallow water aquifers, and so on. And then there are other type of sensors which are essentially gauges, pressure gauges, temperature gauges, flow meters that will go into the well, either permanently installed or run at regular intervals into the well to acquire those data points. There are also a family of measurements of continuous measurement, so such as fiber optics and permanent gauges as well. Those will have continuous access to the data in the well and in the reservoir. So essentially 3 families of hardware, but all of that feed into digital technology, which is essential and important to ingest that data and convert it into insights and actions.
So great. So how do you architect all of these technologies for the economics of the project?
Yeah. No, it's again a complex challenge of optimization. So it starts, and it's very site-specific, very project-specific. There is no such a thing as a vanilla flavor MMV plan. It has to be adapted. So really, it starts with the modeling, as I mentioned earlier. Digital tools allowing us to modeling the reservoir, modeling the subsurface, simulate how the CO2 will behave in the reservoir, where is it going to migrate, what potential risks we may face. Those could be geological risks or other type of risks. And then from there, optimize the measurement in terms, as I mentioned earlier, in terms of what hardware we need to deploy,
Sure.
how we deploy it, and also when do we need to acquire the data points from that hardware? When do we interrogate that hardware, and when do we ingest that data into the model again, to predict or to verify, to predict a change in the performance, or to verify that the performance and the CO2 plume is behaving as expected. So that is the optimization that needs to happen, and it's an optimization of essentially cost, whether that's a capital expenditure or operating expenditure, versus the risk and the insurance of the performance of the site as intended and as planned.
And I was going to ask, let's put it all together and combine it all, and you just did that beautifully for us. So when you're making the choices around the technologies and the frequency of the data collection, this is how you're responding to building your plan, your MMV plan. So there's got to be regulatory in this, I'm sure.
Yes.
So I guess the question would be, when you put the whole plan together, how does it meet the regulatory requirements? And then once you've met those, how do you then develop a plan that's compliant?
Yes, no, very good question. So there are, I would say, 2 aspects to that. So there is the regular reporting to the regulator, whether that's, an environmental agency like the Environmental Protection Agency in the US, or a local regulator, maybe state, or the local community. So that regular reporting is also an output of the MMV plan, as the MMV plan allows basically to ensure that the information is available and it's presented in a format that is compliant with the regulatory requirement. Essentially, that is to reassure and to ensure that the site is performing as intended,
Right.
Primarily from a safety and integrity perspective. And then the second aspect on that side as well, it's to ensure as well that any non-conformance event is reported. And when I say non-conformance event, it could be, a minor loss of integrity in the well. It could be a change from the initial injectivity plan. Different non-performance events that have to be accounted for in a contingency plan when the MMV program is designed. So essentially, when the MMV program is designed, there is a contingency and risk mitigation plan that has to be defined as well, which essentially says that if the performance goes outside certain thresholds, outside certain parameters or an envelope, operational envelope, then a number of actions have to be triggered. And that would include informing the regulator, that would include intervention to remediate the non-performance, and could go maybe in some extreme cases to the interruption of operations as well, which is an extreme case that would have a significant impact on the economics of the project as well. So all of that has to be taken into consideration when developing the MMV program and linked to that reporting and communication with the regulator and with the authorities, whether they are federal, local, or maybe state regulation and state in the U.S.
So what if there is a crisis situation? Let's say you've built out your plan, you've met all the compliance, you've done every step, but there's a leak.
Yeah.
What do you do in a critical event like a leak?
Yes. So then the emergency response plan has to be triggered. So it would include, as I mentioned earlier, communication to the regulator, communication to the local stakeholders. It would include as well a number of measures and actions that would also need to be defined in the emergency response plan as part of the MMV, as part of the permit as well in the US and Canada and many other countries. As part of the permit, this emergency response plan has to be defined, and it will trigger either remediation without interruption of operations, or in extreme cases, if there is a loss of containment of the CO2, interruption of the operation. It could require the change of the injection plan, perhaps drilling some additional wells or different wells and change the injection plan from what was initially planned. But those contingencies have to be accounted for when an MMV program is defined, and they have to be as well part of the permit in many jurisdictions, including the United States.
So a well-laid plan, obviously, is an important piece of it. When you're dealing with the public, the public has to have confidence in the plan.
Yes.
So I guess the question would be, how can an MMV help increase public confidence in CCS?
That's a very good question. I think, CCS is not a new business. I think CCS has been deployed for decades, but definitely now with the scale that we are seeing, public acceptance is important and ever more important and critical. And I think it is reassuring to the public through the regulator and the Environmental Protection Agency to know that MMV program is designed to ensure that there is no harm to the environment or to the public that would happen, that risk is basically managed to as low as reasonably practical. And that through a number of actions. So first of all, as we said earlier, starting by designing the injection site properly, by ensuring that the means of monitoring the performance of the sites exist and are interrogated and are verified on a regular basis, and that information is not only fed into a model to predict any future non-performance event before it happens, but also that is reported regularly as well to the local stakeholders, to the regulators, and so on, reassuring everybody that basically the storage is happening safely and as planned as well. So yes, it's a MMV program is a tool to help basically ensuring public acceptance and to help ensuring that the public is safe and the environment is safe and there is no harmful leak of CO2 or harmful contamination of underground sources of drinkable water, or potentially affecting other operations nearby that could be maybe perhaps, oil and gas operation or geothermal operations or any kind of other operations nearby. So to ensure that there is complete control over the CO2 injection in the site where the MMV program has been designed for.
Okay, so SLB is the global technology company. Mm-hmm. So you mentioned regulation in the US, in Europe. How do you share the knowledge and the best practices to other parts of the world that maybe doesn't have such evolved regulations? How do you take what you're learning in the more developed regions of the world and you take them to more of the parts of the world that maybe don't have access to it?
I think we work in the same direction and for the same objectives as the regulators are setting basically the rules and setting the condition of obtaining a permit or a license to store, and that is to ensure the safety and the integrity of the site, that there is no CO2 that leaks, and then there is no contamination of underground sources of drinkable water and no harm to the public. So we work along the same objectives and for the same outcome, and therefore the technology that we develop and deploy, the workflows that we develop and deploy, help as well fulfill those objectives, and deploying those technology and deploying those workflow globally help transpose as well that learning and help transpose as well basically that experience that we had in certain regions to other regions. I think the regulations follows. The regulations are very much mature in North America and in Europe, and some other regions in the world are still developing them. But I think when the regulators are developing those rules, they look at the technology, the experience, what technology companies like SLB can bring in terms of ensuring, the safety and the integrity and the operational efficacy of a site, and therefore employ that and include that into the regulation that they will set forth. There's no doubt that we have learned a lot over several decades from experiences in Europe and North America, and that is guiding several other regions now into setting their regulations for CO2 storage.
Yeah, that's what I hear when you're speaking about it so beautifully, is that what you've learned, you've also become an educator, someone that, empowers, informs, equips those that might not have had the hands-on experience. So the information and the education piece are so good to hear. That's part of the SLB focus. Thank you so much, Amir.
Thank you.
So your last comment was basically, we all care about why an MMV is important, why CCS needs to be managed with a better plan. And you talked about the atmosphere, what affects us personally. So talk to me about the problem and the challenge we face and why this is so important to address that. So describe the problem and tell me why it's important that we address it.
Very good point. So I think global climate change is affecting all of us. So doing our best to help industrial decarbonization is a big part, of protecting basically future generation from these effects of climate change and what they can be. In this industrial decarbonization, there are parts that are easier than others. There are parts where, you can transition to other forms of energy, we can transition to other products, and then there are the hard-to-abate, or what we call the hard-to-abate industries. So those, it is difficult for the foreseeable future to move away from the processes as they are defined today. And therefore, there will always be, on the foreseeable future, CO2 emissions. How can we then improve and reduce that CO2 emissions from going into the atmosphere and aggravating the overall, problem, the climate change, is with CCS. For the hard-to-abate industry, CCS is the pathway, is the path forward. How we can do it? Obviously, there is the capture part, which is an industrial challenge that has been tackled, and we are tackling it in SLB as well with technology. And there is the transport and the storage piece. The storage is where the challenge can be very, I would say, complex from one region to the other, depending on the geology, depending on the area where we are storing, and depending as well on the volumes and the rate of injection that we need for that particular industrial complex. Now, we need to deploy storage at scale. We need to have storage everywhere there is an industrial complex and there is a hard-to-abate industry that require basically that CO2 storage. And due to the limitation of transportation, we cannot have thousands of miles of transportation pipelines across the countries. We need to have those storage sites close to the industrial emitters. So then the first challenge is, where do we place the site? What is the optimal selection, or how we call it, site selection and ranking of multiple areas around the emitter? Then how do we start planning that monitoring, measurement, and verification in a way that optimize the economics of the project early on, from the design phase, from the evaluation phase, going into building and deploying the right technology, the right measurements, as we said earlier, to ensure first and foremost the safety and the integrity of the site and the operation, but also that we maintain those economics as initially planned and designed, so that we can continue the operations over the decades. Typically, a site will inject CO2 for 20, 30 years, sometimes maybe more. So it is very important. And then now we will backtrack. That MMV now becomes a critical piece into this mission of reducing CO2 emissions and protecting basically overall the planet from the effects of climate change.
So you have a look back. The hard-to-abate industrial piece is you can't just stop the bus from moving, right? The industry has to keep moving. So you're doing a look back. How can we best protect it? And then you have a proactive measure with your plan moving forward. We so appreciate you sharing with us basically the information on how robust the MMV strategies can be, and that they protect the CCS projects. And just even hearing that they ensure and exceed environmental and financial targets over the long period of time, we can't thank you enough.
Thank you very much. Thank you for having me. And it's a great opportunity to share this knowledge and to help scaling up carbon capture and storage around the globe. Because as I mentioned at the beginning of our discussion, it is an essential tool in the global decarbonization. And to reach our basically climate goals that we all have pledged for.
Thank you for listening to this episode of SLB New Energy Conversations.